Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So today in this video we just solved a numerical which is based on the torsion equation, because in the previous video we have done the derivation of a pure torsion here. Now in this problem, so he has given the shaft here, so from that he is transmitting a power, so some data he has given. Now we have to find out some more other terms. Okay, let us move on to this. What we have to find out here for this problem, okay, find the diameter of the shaft, means we need to find out the diameter, so which is transmitting a power of a 60 kilowatt. We just write here. So what he has given the data in this problem is, so he has given the power is given, the shaft is transmitting a power of 60 kilowatt when it runs at a 150 rpm, that is a speed. So the maximum torque is 25% more than the mean torque, as well as, so the maximum permissible shear stress in the shaft is 60 meganewton per meter square. Okay, the next thing is, so the length of the shaft is given, it's a 4 meter, and again the modulus of rigidity, that is a G, is given 80 gigapascal of a shaft here. Now we have to find out the diameter of a shaft, and again we have to find out the angle of twist for that particular shaft here. Okay, now we just write what is the data he has given in the problem. So he has given that the power P is given, so the power P is equal to 60 kilowatt. So that shaft which runs in a speed of 150 rpm is given, and again the maximum torque is 25% more than the mean torque. So means what, I can take this T maximum torque is 25% more, means I had to take, it's a 1.25 times. If suppose 20% more means I have to take 1.20 than the mean torque here. Similarly, maximum torque is 1.25 times the mean torque here. The next is, so he has given the maximum permissible shear stress. So I just take shear stress as tau is equal to, that is a tau maximum is equal to, it's a 60 meganewton per meter square. Okay, I'll take in terms of Newton meter square, so that is a Newton per meter square, that is 60 into 10 power 6 Newton per meter square. Okay, he has given the length of the shaft is 4 meter. So what we have to find out, so we need to find out the diameter of a shaft. So first thing is we have to find out the diameter, and we have to find out the angle of twist. Angle of twist theta we have to find out. So these parameters we have to find out. Okay, how to find out this diameter and the angle of twist? Okay, let us move on to the, so power, since the power is given, some speed is given, we just take the, we just remember the power equation is, we know that power P is equal to, it's a 2 pi n, it's a T mean by 60 into 1000. So this is what the power equation, we already know this one. Now we just substitute the values what he has given in this problem. The power P is your 60 kilowatt, we have to take in terms of the kilowatt because we have taken here in the denominator 1000. So I'll just take the 60 here. So the right hand side is 2 pi, and n is our 150 rpm is given. So we should take the T mean here, we should not take the T maximum because the power is transmitting by considering the mean torque. So the mean torque is not given, so we have to find out. So I'll just take T mean, so this is our 60 into 1000. Now we just cross multiply this term to the left hand side, this is 60 into 60 into 1000. I'll just cross multiply the numerator part here, that is a 2 pi into 150, that gives the T mean. So I am getting T mean is equal to the value what I am getting, the T mean is, it's a 3813.97, sorry, 3819.72. So this is the value what I am getting, that is a mean torque is equal to 3819.72 2 Newton meter. Okay, the next thing is, once if we calculate the T mean, we just calculate the T maximum here. Okay, I'll just calculate what is the T maximum. Now there is no need of the problem here. I'll remove this. Now that T maximum is equal to, it's a 1.25 times the mean torque. So it's a 1.25 into the T mean is, we are getting the value as 3819.72 Newton meter. So we just get the value of, it's a maximum torque which is subjected to a torque, that is a shaft here. So we are getting the value is around 4774.65 Newton meter. Now why we are calculating T maximum? So because we know that the torsion equation is what, it's a T by J is equal to tau by R is equal to G theta by L. Okay, where we can calculate the diameter and the angle of twist. So we know that the torsion equation T by J is equal to tau by R is equal to G theta by L. Okay. Now first thing is, I will consider the first and second part here, that is, consider T by J is equal to tau by R. So here the T is nothing but it's a maximum torque in the torsion equation. This is a maximum torque here. So now this is a maximum torque. We have got the value of 477.4, that is a 0.65. So this is the polar moment of inertia for a circular shaft is pi d power 4 by 32. Now this is a maximum shear stress. So he has given 60 meganewton per meter square, that is a 60 into 10 power 6 I'll take. So this radius of the shaft is, it's a diameter by 2, that is a d by 2. Now in place of T maximum, I'll substitute the value of 477.4.65. Now the polar moment of inertia, that is J, is our pi d power 4 by 32. So that is equal to, the tau is nothing but it's a tau maximum which is given in the problem, that is a 60 meganewton per meter square. So I'll take 60 into 10 power 6 Newton per meter square. Now the diameter radius is our d by 2. Okay. Now the simple thing, 2 ones are 2, 16s are, so 1d 1d get cancelled here. The 16 will go to the numerator. We just simplify here. So this 16 will go to the numerator. So the remaining part is 4774.65 by, so here the pi is there and d cube we left here. So that is equal to, so on the right hand side we just have a 60 into 10 power 6, 60 into 10 power 6 is there. I need to find out the diameter d, so I'll just take this part to the right hand side and 60 into 10 power 6 I'll take in the denominator part, which gives, so this is pi is there, so 60 into 10 power 6, that is equal to d cube. Once if you just simplify this, after taking the, okay, once if you simplify you will be getting some value over here. Now after that we just take the cube root of that, so that we will get the diameter value here, that is therefore, so diameter d is equal to, so the value what I am getting around is, it's a 0.074 meter. I can write this as some 74 mm also. Okay. The next thing is what we have to find out the angle of twist. This is our first part. Now we just consider to find out the angle of twist. So T by J is equal to, I'll just take the G theta by L value. So again here the T maximum. So J is a polar moment of inertia pi d power 4 by 32. G is a modulus of rigidity. This theta is unknown and this length is that is the length of the shaft here. We just substitute the values over there. Now the T is nothing but T maximum. 4774.65. So when we are substituting the terms, we should have to keep in mind that so entire term should be either in terms of mm or either in terms of the meter. Now better I'll take here in terms of mm here. So this T is nothing but a Newton meter we have taken. So I'll just take in terms of mm now. So because this is the T maximum is our 4774.65 Newton meter. So once if I multiply 10 power 3, it becomes a Newton mm. Okay. Now polar moment of inertia J is pi d power 4 by 32. So diameter I have to take 74. It's not 0.074 meter. Now I am taking in terms of the mm here. So this is 74 to the power 4 here. Pi d power 4 by 32. So that is equal to, so G is, so he has given in terms of 80 gigapascal. So 80 into 10 power 3 megapascal, because so G what he has given, 80 GPa is given. So this is 80 into 10 power 3 megapascal, because the 1 megapascal is nothing but 1 Newton per mm square. Okay, that's why I have taken 80 into 10 power 3. So into theta, by length of the shaft is given is 4 meter. I'll take in terms of the mm is, that is a 4 into 10 power 3. Now once if we just simplify, we will be getting a theta, that is the angle of twist in terms of the radians. Okay, that value what I am getting is 0.081 radians. 0.081 radian. If I want in terms of the degrees, so just multiply 180 by pi, that is 180 by 3.14. So we will be getting theta is equal to some degrees here. So that is value is around 4.64 degrees. I hope you are reading this problem here. It's a very simple. Only thing is what we have to remember the equation, that is the torsion equation. Along with that, once if the power is given means we have to remember that power P is equal to 2.80 by 60. That's the equation here. Based on that only we can just able to solve, and we can find out the diameter as well as the angle of twist.